Hey class, this is Dr. Martino again. This is the second video that I'm making for this COVID-19 respiratory short stack. It'd probably be the last one for this. I think we're just going to keep it to 2 respiratory videos because the respiratory is so challenging to begin with. You can listen to the longer lecture as soon as I find it. But if not, just reading the chapter and these 2 videos will probably give you most of what you're going to need as you move on. Of course, we could fill in the gaps at a later time. So this graph that you see here is called the oxygen or the hemoglobin dissociation curve. So what does that mean? So let's try to blow this thing up a little bit. 72. Okay. So move this over. So this is there are 2 y-axes here. The percent saturation, in this case, happens to be on the right. Oftentimes it's on the left. This is the information that when you're in a hospital, you will hear doctors and nurses talk about the O2 sat, right? And what they're talking about is the percent saturation of hemoglobin. So you can only get 100% saturation. What percentage of that is saturated? A normal person, healthy person, will usually have an O2 saturation between 95 and 100%. The normal range for saturations actually go from about 80 to 100. And we'll talk about why you don't want to be at or below 90 in a sec. So that's this part of the curve right here. On the second y-axis on the left is the volume percent of oxygen. So this is the concentration of hemoglobin. It goes from 0 all the way up to 20, and you can see 20 corresponds to 100%, 15 roughly corresponds to 80%, 10% roughly corresponds to about 55%, and 5% roughly corresponds to about 30% sat. On the x-axis is the partial pressure of oxygen in millimeters of mercury. Okay, let's talk about what these are and are not. The percent saturation and the volume percent, right? The volume percent have to do with the actual hemoglobin molecules. Remember, a hemoglobin molecule, every molecule of hemoglobin can bind 4 oxygen molecules. So what percentage of those 4 slots and all of the hemoglobins are saturated? So that's what these 2 curves are essentially talking about, these 2 axes. The x-axis here is the percent of partial pressure of it's the partial pressure of oxygen in millimeters of mercury. This comes from the oxygen that is dissolved in the blood, in the plasma. This percent volume comes from what is bound to hemoglobin. Okay, so the amount that is bound to hemoglobin versus the amount that is dissolved in the blood. Most of the oxygen is bound to hemoglobin. A very small percentage of the oxygen is dissolved in the blood. So you got to keep those in mind. Bound to hemoglobin, dissolved in the blood. You cannot get a PO2 from hemoglobin. You can only get a PO2 in millimeters of mercury from what is dissolved in the blood. Similarly, if you wanted to know the partial pressure of carbon dioxide, you could only get that from the dissolved amount of carbon dioxide in the blood, not what would be bound to hemoglobin. Okay, so Now that we have that established, most people sit between 95 and 96, but between 80 and 100 is considered normal. The main curve is this big curve here. And this is a sigmoidal curve, right? It's a sine wave, and it would do this if it were to continue. That shape of that curve tells you a lot about how your body responds, how it utilizes oxygen. Because for the most part, if we take a look at this, right, we go from 100 millimeters of mercury, that's roughly 96% saturation. And as we move to the left, right, we get to 90 and we go up. Saturation's still pretty high, 95%. And as we go down to 80, it's still pretty high. It's like 93%. We go down to 70 and we're still above 90. We go to 60 and we get to about 90. So what does that tell us? It says that you can have a 40 millimeter of mercury drop in the partial pressure of oxygen dissolved in the blood and still be in a good percentage of saturation. So you're not going to have a problem. There's some benefits to that, right? When you go to altitude, you go to Mile High Stadium in Denver. When you go to other places like Leadville, Colorado, which is 10,000 feet above sea level, you're going to get partial pressure drops that are pretty large because there's just simply less oxygen molecules at those elevations. But your system will compensate, and it shouldn't be a problem because it has all of this room from 100 to 60, and it's still fine. So that's important. Now, what happens? So this part from about 100 to 60 here is considered the flat portion of the curve. It's the plateau, essentially. And that because of the shape of that curve, because it's in the plateau region, 60 millimeters of mercury to 100, that means that you can have very large changes in the partial pressure of oxygen and have very small changes in percent saturation. If instead this curve was a 45-degree line, then you would have a 1-to-1 change in percent saturation and PO2. That would be a disaster. That would mean the slightest deviation or decrease in partial pressure would severely decrease your percent saturation, and you would have many problems doing many things, just walking around. Okay, so it's the plateau and the sigmoidal shape of this curve that prevents you from having problems. That's an important point, right? It's a law of chemistry and physics. What happens though once you start to get below 60 millimeters of mercury? When you start getting below 60 millimeters of mercury here, right, you start to get into the steep portion of the curve. And actually, if you draw a line from 80 over, you can get to about 45 millimeters of mercury, and you can still be sort of okay. Once you get beyond that, it drops off precipitously. That means that you're going to have huge changes. So let's just take it from the Venus point here. That's what that V represents. Huge changes in percent saturation with very small changes in PO2. Okay, so what are the take-home messages? One, you need to memorize the curve. You should be able to draw this curve or label this curve. So that's one. If you don't do it now, you're going to have to know it in medical school, PA school, whatever. Number two, you need to know what part of the blood each one of these axes is coming from. So this part is coming from the hemoglobin, that's what this is being measured in percent. And this part, the x-axis, is coming from dissolved. Two different parts of the blood. This is dissolved, this is not. This is bound to hemoglobin. Number 3, everything that happens to percent saturation, and PO2, those characteristics happen because of the shape of this curve. So the shape of this curve tells you the reaction characteristics of hemoglobin and oxygen binding and unbinding, right? And that relationship is denoted by a sigmoidal curve. So the curve is essentially what determines how this all happens, right? It's the curve, because the curve is telling you the relationship between oxygen and hemoglobin. If it wasn't sigmoidal, if it was a 45-degree angle, it would be harder to be alive under adverse conditions, such as being at altitude or being slightly hypoxic. So there's a plateau phase, plateau portion, that's point number 5, and then there's a steep portion, that's point number 6. And so if you understand where all these numbers come from and what this is, that's the majority of what you need to know. These additional curves here are for disease conditions. This one is for pathological conditions. Carbon monoxide poisoning and what happens to the curve. And this third curve here is for anemia. I'm not going to test you on that, but it's something interesting to know. And you can see that in the next graph here, which is several slides down, 1, 2, 3 slides forward, we talk more about that. And if we were in class and we would be discussing that more completely, then I would hold you accountable. So I just want you to know the basic gist of this curve. So at this point, you should know the basic mechanics or the foundational mechanical ideas for the lung, and then the O2 dissociation curve. And those are probably the two most important things that you can take forward with you, no matter where you go to graduate school or professional school. And again, definitely look over the rest of the lecture because it's important, but these are probably the two most important points. Hopefully that makes sense to you. If not, definitely give me a call, email me so we can chat. Have a great day.